Hello everyone. Today I'd like to talk about the concept of skill space, our proposed method of representing developer expertise in the context of open source software. I am Tapajit Dey and I worked with Andrei Kurnaut and Dr. Audris Moskos in this paper. I was a PhD student at the University of Tennessee at the time of submitting it. And now I'm working as a postdoctoral researcher at LERO, the Science Foundation Ireland Research Centre for Software. As you can see from the logo up top, this paper leverages the World of Code dataset. The number of open source software developers and projects have reached staggering heights in recent years. This makes answering questions like who can be trusted to be a contributor to a project and which projects a developer can contribute to particularly challenging. Generally, to be accepted as a contributor to a certain project, the developer must earn the trust of the project maintainers, which is typically generated through repeated interactions. While this has its own benefits, it becomes exponentially difficult as the projects grow and more potential contributors jump in. To borrow a quote from a recent paper, as contributors scale, project maintainers must devise ways to scale trust as well. But the questions of which project is right for a developer and vice versa are not very straightforward. We can take a stab at it by focusing on what the projects want and the developers are looking for. Typically, a project wants someone who understands the code base and is skilled enough to improve it, while developers either want to work on things they are skilled at or want to learn new technologies by working on a project. So the bottom line is that the relevant skill or expertise is important while trying to figure out the right developer or the right project and scaling up the process as projects grow in size. Now, there have been a number of studies on developer expertise. However, so far, most of the research on developer expertise has either been too general, looking at the breadth of a developer's activities, or too specific, focusing on the individual files modified and the so-called experience atoms. However, to satisfy the goal of finding the right developer or the right project, domain expertise is much more suitable as a measure for relevant skill, which we propose can be estimated by looking at the APIs used by a developer. So our research goal is to define a measurable representation of a developer's expertise for specific focus areas of software development by gauging their fluency with corresponding APIs. To that end, we propose the concept of skill space, which offers a vector representation for developers, projects, APIs, and even programming languages, where they can all be represented by their corresponding skill vectors, and these vectors can be used to measure the similarities and differences among these entities. So essentially, the skill space is like the proverbial place for everything in the context of software development, of course, where everything has its own place. A quick summary of the process that we go through to create the skill space is as follows. We collect the required data from the World of Code dataset, and after some data cleaning, we selected all files in 17 programming languages, extracted all the blobs that are related to these files, and identified the authors for these blobs. We then extracted the APIs related to these blobs. We wanted to focus on the ordinary but productive developers, so we elected to only look at the developers with between 100 and 25,000 commits and created the input file to be used in the next step. In this input file, each of the lines represent one blob created by one developer and contains the information on the language, the repository where the blob was created, the timestamp for blob creation, the ID of the developer who authored this blob, and the APIs used in this blob. For the details of the process, please see our paper. Now, we decided to create the skill space by using the doc2vec model on the input file, because a naive embedding would result in vectors with about 100 million dimensions, because that is the approximate number of total APIs that are out there. And such an embedding would also likely have very few overlaps. So for this doc2vec model implementation, the document refers to the description of each blob creation, where the authors, projects, and languages are used as document tags, and the APIs used in this blob are used as the words in the doc. For the specific details on how we use doc2vec and these particular parameter settings that we use, please see our paper. So we use the Python GenSim framework for our calculations, and The alignments between the skill vectors were measured by the cosine similarities among them. A few example calculations are shown here. As you can see, matplotlib, numpy, and seaborn were found to be the most similar to the Python pandas library, which intuitively makes sense. And this implementation even allows for cross-language comparisons. For example, the R library's data table and dplyr were found to be most similar to pandas, which is surprisingly accurate. Now, for further evaluation of our proposed skill space implementation, we tested 5 hypotheses about the postulated properties of skill space. The first hypothesis we tested looked at if, given the history of a developer's activities, the APIs they use in future are more closely aligned with them in the skill space compared to random other APIs that they did not use. This was tested on a sample of the whole data set with about 36,000 projects and 1.2 billion blob changes performed by 690,000 developers, since otherwise it would have taken a very long time, a few months at least. And we found that our hypothesis, in fact, is correct for 16 languages, except for Fortran, for which we unfortunately ended up having too few samples. The second hypothesis we looked at was whether the new projects a developer joins in future are more closely aligned with them. For testing this, we created the skill vectors for the developers and the projects they joined in future, and random other projects they did not join using past data, and compared the differences between the alignments of the skill vectors for the two sets, the developers and the projects they joined, and the same developers and the projects they did not join. And this difference turned out to be significant. Similarly, our third hypothesis, which postulates that future contributors to a project are more closely aligned with them than random other developers who did not contribute to the project, was also tested in a similar fashion and was also found to be true. For the fourth hypothesis, we used a pull request dataset from a previous study and added the alignment between the project and the creators of the pull request to that project as an additional variable. We found that the alignment variable was significant even in the presence of the other predictors that were used in the previous study, which itself had achieved a very good performance. This goes to show that the alignment captures an aspect that is not described by the existing socio-technical signals. Finally, using the dataset from a previous study, we wanted to test if the developers' self-reported expertise in different APIs match with the alignment of their skill vectors and that of those APIs. We investigated if the skill space similarity between the developers and the APIs can be explained by their self-reported expertise and vice versa, and found that the two variables do indeed explain each other. The artifact associated with this paper is available online through Zenodo. In fact, our paper was awarded the prestigious Available badge through the artifact evaluation. The shared dataset has the input data used in this paper, all the scripts that we used for conducting all the experiments, and as well as the pre-trained models, which would make using this dataset much easier for someone who just wants to use it directly. The full dataset is always available from the World of Code dataset. So, in summary, in our paper, we have introduced the concept of skill space, a method of estimating the developer's medium-grained expertise or domain expertise, where it is possible to have embeddings for the developers, projects, languages, and APIs. And calculations with these skill vectors is very intuitive and straightforward. The associated artifact has also been shared through Zenodo. So we hope that you will find this talk useful. And if you have any questions, feel free to ask them right now or drop us an email at tapajit.day@lero.ie or audris@utk.edu. Thank you for watching.
The strength of so we're not asking how expert you are.
Hi everyone, we are live now. I'm Daniela Danian from University of Victoria, and I'm your session chair for the question and answer for the paper Representation of Developer Expertise in Open Source Software. I'm joined by the two authors of the paper, Tapajit Day, thank you for your great presentation, and Audris Mokas. Tapajit is now a postdoctoral fellow at University of Limerick in Ireland. He did this work in collaboration with Audrey Smokus, who is at University of Tennessee. Two questions already popped up. So I'm going to first start with the one from Alex, whether women, if you saw any differences in women, they're likely to experience the confidence-competence gap differently. Would this mean that their self-assessment of skills and their skills vectors would be less aligned than those of men?
Yeah, so I'll start with that. So basically, we did not take the genders for this study, but if Dr. Oscars has something to add on that.
Yeah, I did in the chat. So the measures are, so basically the proposed measure, it really measures the direction, not the strength. So it doesn't say, it's basically it's saying, which area you're aligned with, not necessarily how skilled you are in that area.
Ivan is asking about your skill vectors and how would you be able to augment it with quality measures? For example, a developer may have committed lots of pandas code, but it is of terrible quality. So the quality of contribution, is that considered in your skill vector, or how could you augment it?
Yeah, that is a great point. We just looked at the code. The quality aspect was something that we did not study for this one, but that I think that's a very good point. That should be added also in future.
So especially if we want to measure the strength. So right now, the current proposed measure has absolutely no indication of actual amount of skill. Just shows where you're in the full space of APIs are directed. So I think if one wants, and that's of course undesirable because it misses a lot of stuff. But if we were to add it, I presume one would want to also measure some measures of quality. If you have any suggestions on how best to, it's a very controversial subject, how best to tell, good versus bad code, that'd be good. But that's definitely some future work.
A question from Colin Werner is about developer and project attributes for a match. When you look at the projects that a developer did not work on, which obviously would be smaller compared to the number they worked on, did you consider that in your skill vector? How many of the projects they did not work on?
I don't understand this question completely, but what I think is that, so the API, what we studied is basically based on the code that they have changed. The code they have not changed, we don't have anything for that.
Well, I mean, just to make it more precise. So the way that Doc2Vec works is that it takes all the data, including the project that the person did not work on, but the person is not, figuring in these projects. So the projects in which they did not work on, they don't have any alignment, right? But other people get alignment on these projects because others worked on it. So this is really kind of asking about exactly how the nature of how Doc2Vec works. But I think it takes account the projects that you haven't worked, but not in a kind of a direct like regression way. I don't know if I answered the question sufficiently, Carl.
Ivan is wondering if the comment can be rephrased as using negative information, as in the projects that the developer didn't work on would be the negative information, supposed to just relying on positive information, which is the projects they worked on.
Yeah, go ahead, Tapajit.
So one thing we did is that basically we had attribute of negative sampling. So the process, what it does is that it creates some samples which are incorrect and actually penalizes the model if it predicts that sample. So that is the only way I think that has been done, which is kind of similar to that. But that's all we have done, I think.
Right. So apart from negative sampling in Dr. Vec, we haven't really added anything explicitly. But just to respond to Ivan's comment is, I think what you're suggesting is perhaps the following: is if we see that people who use this particular set of APIs also use some third, so they use A and they use B a lot. All the people who use A and B a lot, they use also C a lot, right? So what you want to probably do, and we haven't done that, you want to detect people who use A and B but do not use C, and kind of use that as a negative indicate, as somehow distinguish them from the ones that use A, B, and C. This is an interesting idea. I don't think we've done anything on it so far.
Yeah, that is true. Yeah, that's I think that's also great future work to do.
Direction. Yeah, further analysis. Sounds good. Colin is happy. Right. And Ivan is happy. I also had a follow-up question while waiting for other questions. Was there anything that surprised you in your results? Like all your hypotheses, like I kind of intuitive, like of course a developer would, if the APIs match their skills, they would choose that API, right? Like what would you have gotten to surprise you in terms of results?
So let me start with that also. So one thing we found kind of surprising is the cross-language comparison, because that is something that we did not explicitly train for. But since a lot of projects have like various languages, and it worked out really well. So that is something that we did not anticipate, but it was a good thing to see also.
So the other thing that I would mention that was somewhat surprising, we actually kind of didn't have really much hope starting with this. But for example, when we predict the project's participation, the API usage or project participation usage, we use only the data in the past. So we really know that the person used API A, and we know that API A is associated with API B. And then we're trying to say, well, will the person more likely join projects or use API B, projects with API B, or where that are similar aligned with it, are more likely in the future or use that API in the future, and they did. So that was kind of somewhat surprising, because we're really not trying to say, well, you use this API, you will use this API in the future. It was a little bit different, right? And the dimensions of APIs is pretty hard. There's just Java has like a few million distinct APIs. So that's there's no particular reason to believe that would happen. Sorry for a long answer.
No, that's good. We have about a minute left. Just we will be taken off live suddenly. There's a discussion about possibilities for future work, the non-associative learning. Although Ivan says that it may have been done already. I don't know if you have any comment on that, Andres.
I'm looking through it. Thanks for response. It's a hard problem. I wonder if columns are retraced. Okay. Kirsten, but not both flow. I really don't understand that. Non-associative, though, this is recommended. Then most of the. Actually, I don't really understand the comments. I'm sorry.
That's all right. That's all right. I have a quick question at the end. Any implication with respect to further, like a self-assessment protocol that developers can go through to understand maybe a certain match to projects and APIs? Is it possible? Is it useful?
You can.
Well, so there's a couple of things. So what we tried to do so far is just to prove feasibility that there's possibility to find it. What we think would be next steps is to find something that's more resilient, right? So you can't fake it, that actually has magnitude.